Okay, let's start looking at question number 1 and see how we get on there. The first bit we're looking at Suvat equations. We want to find A, the acceleration. What do we have? The first bit you could write down, or should have written down, is the Suvat, and then start going through the question, looking for the key bits of information. They talked about the rocket moving from rest. That means the initial velocity u is going to be 0. You also see that the description in this sentence is about the first 3 seconds. So we're looking at t being equal to 3 seconds as well. And then the rocket rose 27 meters. So we have s, a displacement of 27 meters. Now that's all that we have. We want to find a. We do not have v. We do not have a final velocity here. So we look at our Suvat equations. We're running through them in our mind. Which one can we use? And it's going to be the third one I have from the list here. S is equal to ut plus a half at squared. That's going to get us the solution that we want because we have s, u, and t, and we want to find a. So substituting in that equation, we have 27 is equal to 0 times 3. That'll reduce to 0 plus a half a multiplied by 3 squared. 3 squared is 9. As we start to simplify that, what it reduces to is 9 on 2. A is 27, which means that 54 is 9a, and a is going to be 6. That's your answer. A is equal to 6. Now, can I just point something out? Let's look at the mark scheme. M1, your method mark, you're going to be getting that for showing that you can use the formula, selecting the right formula, and then accuracy, A equals 6. No, we did not say A is equal to 6 meters per second squared because, well, no, look how the question is structured. It said a constant acceleration A meters per second squared. So the value of A is just the magnitude of it's just the size of the acceleration. You did not need to put in units. You will see in other questions where units, you do need to have the units in the answer, but make sure you read your questions properly so that you're clear if you need to put in units or not. Okay, moving on, part B. We're now told that the speed of the rocket, we want to find the speed of the rocket 3 seconds after it left the ground. We have the acceleration from part A, so we know the acceleration is 6 meters per second squared. And if we want to find speed after 3 seconds, we want to find v. We want to find a final velocity. Considering the Suvat equations again, v equals u plus at will do the job perfectly here. So that's the equation we're going to substitute in. And as we substitute in v equals u plus at, 0 plus 6 times 3, 18 meters per second squared. Meters per second, sorry, not meters per second squared. Now, note in this particular instance, and you get for the method and for your accuracy, your 2 marks there. Sorry, I'm going too fast. Let's just go back. Note we did use the units here because the reality is in this question, there's no reference to v. Okay? And there is no units. It's not a situation where they're saying it's v meters per second squared. They didn't say it, so you have to make clear that v is 18 meters per second squared. So this is an example of where the units would be expected. And again, as I said when we were looking at part A, make sure that you're reading the question thoroughly to be clear on if units are required or not. Be carefully guided. Finally, part C. Now, so far, and this is a bit of a curveball, they've added a new sentence here. They said after 3 seconds, because for part A and part B, we were only dealing with what happened to the rocket in the first 3 seconds. Now the story goes that, well, after 3 seconds, the rocket burns out. Uh-oh, no more, nothing's pushing that rocket up again. It has to rely on the what it has already, what juice it has already, shall we say. It's now moving freely under gravity. So in other words, A, from 3 seconds onwards, A is now minus 9.8 meters per second squared. It's not 6 anymore. There is no force propelling it to get to 6, gravity is now doing its job, and that means that rocket is going down. It's going to get down eventually, isn't it? But we want to find the height. We want to find S displacement, height, and after 5 seconds. Okay, we already know what happened for the first 3 seconds. We were told that in the question in the first 3 seconds it rose 27 meters. So actually what we're concerned about now is what happens for the next 2 seconds from t equals 3 to t equals 5. That at 3 seconds, what we worked out previously, part B, was that the velocity is 18 meters per second, and that is now our initial velocity because we're starting at that 3-second mark. And we also know that we're moving for 2 seconds. That's what we're interested in. So again, we can use S equals ut plus a half at squared to find out, to get the second part of our overall distance, to find out what's happening for those from 3 seconds to 5 seconds. Substituting, which is substitute into the equation, a is minus 9.8, t is 2, u is 18. And once we punch that into a calculator, you're going to get a distance of 16.4. 16.4 meters is what it's going to be. And that is not your final answer. Remember, we want the height of the rocket after the 5 seconds. This is how much displacement took place from 3 to 5 seconds. So to get the total height S, we need to actually add what happened in the first 3 seconds to what happens in the next 2 seconds to get the total height. So after 5 seconds, although the acceleration, the rocket is burning out, it's still going upwards, and it actually gets to 43.4 meters. So that's your answer for part C. What you needed to do, just running through that again, we already had a distance for the first 3 seconds. You needed to remodel things to find out what distance it travels for the next 2 seconds from 3 to 5 seconds and add that on to the original distance that we were given. Did that and you were totally sorted. That's the solutions for question number 1. In terms of marks, that's how the marks are being allocated for this particular question. So two marks for getting getting the additional distance, and then another 2 marks for getting showing clearly that you knew you needed to add the distances, and for adding accurately. That's your method and your accuracy mark there. Okay, so that's the first question we had to do sorted. Make your corrections as appropriate, and then you can move on to the next question.